Chapter 14.
Test.
Sorry, sister.
On this plane? Yeah. I'm zooming it to you. Do you
Okay.
see that?
Uh-huh.
Mm-hmm. This is what you're supposed to do. Even this is another easy peasy thing. Everything is on calculator. So you are going to go to stat and then move on to test.
Mm-hmm.
Okay, and then select option number 7.
Okay.
Do you see the Z interval?
Yeah.
That's right. So that's what is going to be selected. And then you will see the input screen. The input screen has two options. One is going to be the data. The other one is the stats. So I'm going to be selecting stats because I'm given the sample mean X bar and the sample size is there. And then the population standard deviation is there. So I'm going to select stats. Do not select data. Only if you are given the data of 269 observations, you're going to select data. But here, since I'm given the numbers right away, I'm going to select the option stats. So just check, plug it in. Your sigma value, plug it in. Your X bar value, plug it in. Your N value, plug it in. And then your C level, whatever is the level, confidence level given in the problem, plug it in. And then hit calculate. Boom, the output screen is going to give you the lower limit and the upper limit. Go ahead.
So mine doesn't say N value or X value. It says least and frequent.
Oh, no, only if you select data, you get those options. Do not go for data. Go for stats.
Oh, yeah. I see now. I see.
Do not go for data. Only the data will give you the frequency and then the list and everything. That's what I'm saying. Only if you're given 269 observations in your data, then you need to go for data and you have to plug in all the observations into one of the columns. Remember, we have about 6 columns. Those 6 columns are editing. You are going to use the edit option to plug in the 269 observations. But we are not given the data. We are given only the mean, right? So go for stats.
Okay, got it.
Once
Thank
you
you.
plug in the stats, this is what you will be seeing.
Uh-huh.
That's what I put the X mark for the data. That means you're not going to choose that. Go for stats. Then you get sigma, X bar, and C level calculate. So just plug in every single information that you have and then hit enter or calculate, then you get the output screen. So this is what your output screen will look like. This is the output screen.
Yep.
This is what you're getting now. All right, good. Sounds good. Perfect. All right. So I guess everybody is comfortable with the TI. So you are going to use the test. Okay. All right. So we have seen the various concepts here, and then finding the lower boundary, and then the upper boundary, and then the margin of error, which is going to be either side from the center. That's right. That's what I call it as the margin of error. And then between the lower boundary and the upper boundary, you are going to have the confidence level, which is 95%. We always put the number as a 90%, 95%, or 99%. The perfect number is the 2 sigma limits, which is the 95%. All right. So that is the best number, the confidence level number. Most of us will do only 95%. But still, in your problem, I am giving you various confidence levels so that you will understand the significance of the critical value, how it changes as you keep increasing the confidence level. And the formula is going to be the same, but only thing the C star is going to be replaced by the critical value. All right, so we have seen some deduction result. As we keep increasing the sample size, your margin of error is going to be dropping. And then as you increase the C level from a smaller number to a bigger number, obviously the margin of error is going to be enlarging, and that way your confidence interval gets wider or gets bigger. But if you shrink it, that means the margin of error, if you want to have a smaller number, in that case, you need to increase the sample size. So when you increase the sample size, your sigma over square root of n goes down, and as a result, the margin of error is going to be going down, and the interval is going to be shrinking. So this is the concept that we said in our results or the deductions. So that should be somewhere in your, yeah, here it is. Here it is. So my focus is going to be on chapter 15. So we are going to find how to predict the sample size with the given margin of error. So we are seeing that three guys are pulling each other, and I see there is a connectivity between the sample size and the margin of error and then the C level. So I just got you the new formula with the given margin of error, with the given C level, with the given sigma, you are going to find the sample size n. So the sample size n is given by the formula Z star. That is coming from your confidence level, and then the sigma, the population standard deviation over the margin of error, and don't forget to square that. If you are not squaring it, you are solving for square root of n. But we don't want the value for square root of n, we want the value for n. So remember to square that at the end. That will give you the sample size. So most of the problems in chapter 14, you have the answer key, and maybe these are all the extra problems that I have posted. If you want, you can try that. And I'm going to try only one problem with the data. So this is the problem taken from your book. So from the extra problem collection, I'm going to be doing the second problem. Okay. All right. So here you are not given the X bar. Instead, the data is given. So this is where I'm going to be using my L1. Okay. So here the sample is going to have the three observation, and the three observations are going to be 8403 and then 8363, and then this problem is taken from your textbook though. So you are given the four observations, sorry, the three observations. All right. And then what is the number coming from the population? The number coming from the population for your reading, it is going to be 0.0068 grams. So this is the number coming from the population, which is the standard deviation. And what is your goal? Your goal is to find what is the probable limits for your population in you. So now you are going to find the true concentration confidence interval for mu. So basically, you are going to find probability of your mu is expected to fall between how confident you are, 95% confident. So you are going to get the lower boundary and the upper boundary. All right. Since my data is given, I'm not given the X bar value, and I'm not given the yeah, only the X bar value is missing. That is correct. The sample size is there, the sigma is there, and then the sample data is there. So now I am going to go to stat and then go to the edit option. You know how to use the edit option. So you will be given the 6 columns, and now you make sure you plug in the numbers into any one of the 6 columns. So you are going to have about 6 columns, right? So now you are going to plug in the numbers in any one of the 6 columns. So the columns are going to be L1, L2. This you have already used for getting your one variable stats, and then you have already used these columns for getting the R value, the A value, the B value if you are given the bivariate quantitative data. So now what I'm going to do, for me in option number 1, go to stat again, go to stat and then choose option number 1, edit. So for me, L4 is available, so I'm going to plug in the data, which is 0.8403, hit enter, and then the second observation is 0.8363, hit enter, and then the third observation is 0.8447. Hit enter. So I have entered all the three observations in L4. So 0.8403, hit enter, and then 0.8363, hit enter, and then 0.8447. So I have all the four observations entered in L4 because in my TI, L4 is available. I used my L4 to plug in the data. All right. So the data is already entered and the data is ready. Now go to stat and then move on to test. Now you go to stat and then move on to test and select option number 7, which is Z interval for mu. Z interval for mu. I want you to select option 7. So I am going to move the cursor down and select 7. So I get the input screen. The input screen is going to be, there are two options as you see, and the second one is stats. Now this time I am going to select the data. I'm not going to be selecting the stats because the data is given to me. The three observation, the data is given to me. So now you are going to be selecting the data. So I am going to select the data. So once I select the data, I see the sigma value. So which is going to be sigma in my data. It is 0.0068. 0.0068. All right, plug it in. And then now it is asking where the data has been stored. Let me plug in 0.0068. So move the cursor down. Now it is asking where the data has been stored. I don't know where you stored your data, but in my case, I told you that it is in L4. So the list is available in L4. So hit the second L4 because all L1, L2, L3, L4, L5, 6 are in blue color for me. Some of you will have it in yellow color. So if you want to hit the second button, push second and then L4. Okay. And then move the cursor down, second L4, and then move the cursor down. The frequency is 1, which is a default. You don't have to touch that. It is going to be 1. Don't touch that. It is 1. And then move the cursor down, the C level. The C level is a 95%. Plug it in as 0.95 and then hit calculate. And then hit calculate. So I'm going to hit calculate because I have my data in L4 all done. So now I'm going to get the output screen. The output screen is going to give me the lower boundary number and then the upper boundary number. This is what I'm getting. And then my X bar. The TA is giving me the X bar value, which is 0.8404. All right. So this is what my TR is giving me. This is the sample mean. So this is the sample mean. This is the sample mean. And for the tiny data with 3 observation, my TI is giving me the SX value. What is that? It is 0.0042. So this is the standard deviation coming from the sample, which is the sample standard deviation. You know how to get this number because the TI is doing what is the SX. XS is going to be square root of every single observation measured from the mean, the whole squared over n minus 1. So this is the formula for the sample standard deviation SX. Okay, so the TI is calculating the sample mean and the sample data, and it is giving you those two numbers in your output screen. But what we need here is just the 95% confidence interval. So the 95% confidence interval is going to be between. So the bottom number is 0.8327. That's going to be your grams per liter. And the top number is 0.8481. 0.8481. All right. So this is how we are going to be doing when the data is given to you. So when your stats are given, you're going to choose the option stats. But instead of X bar, if you are given the data without the X bar, make sure to plug in the data before you move on to option 7, the Z interval for you. Okay, so make sure the data is available in any one of the list. You are given 6 lists: L1, L2, L3, L4, L5, and L6. Okay, so plug in the data, make sure the list is available, because when you use the data, it is going to ask you the list of data. So for that, you should be ready to tell where the data is available. So your data is available in L4, so you are going to bring the data from the fourth column or the L4 column. The frequency is a default 1, don't touch it. So I am going to put that 1, which is a default. You don't have to touch that. It is anybody has any question about this part of finding the confidence limits for you? Anybody has any question if the data is given? So I have shown you one problem where when the data is given, this is what you're supposed to do. Anybody has any question? Are you all working with me with TI? Everybody getting the same screen that I got?
Yes, I do.
Super good. All right. So these are all the problems for you to do, and you can try everything is on TI option 7. That's the only thing. Okay. All right. So now I am going to move on to chapter 15, finding the sample size. So you are given